Hello everyone. Today we're going to be doing 704 binary search. And it says given an array of integer nums which is sorted in ascending order, an integer target, write a function to search target and nums. If target exists, then return its index, otherwise return -1. And so basically example 1 input nums is -1 0 3 5 9 12 and the target is equal to 9 and the output is 4. And here, I'll show you guys a visual explanation of how binary search works real quick. Sorry. Okay. So basically, how binary search works is that like there's always a middle value, and you would need 3 variables for that. You need a left, mid, and right. And the right will be at the end of the array, and the middle will be left plus right divided by 2. But you'll floor division it. So basically, floor division is like 5 divided by 2. 5 divided by 2 is 2.5, right? But floor division puts it at its lowest common value, which is 2, lowest value. And then the left pointer would be at 0. And basically, for binary search, to calculate the middle, left will be right here, right will be right here. So you're going to calculate the index, which is 0, 1, 2, 3, 4, 5. So as you can see, left plus right divided by 2. So it would be 0 plus 5. And these are indexes, keep in mind, divided by 2. And it is 2.5. And with floor division, we know that it is index 2. And index 2 is at 3. So we know that the middle value is currently at 2 right now. At 3 right now. So mid equals 3. And basically, we see that the middle value is less than the target value. And since that the middle value is less than the target value, you want to get rid of everything right here, including the middle value. And then you're going to shrink the window size. And this will be the new array. So you also remove the current middle value. So this is where you increment like the left pointer to mid plus 1. Just so you don't include the middle value. And right here, your new array will be 5, 9, 12. And every time you do this step, you're going to want to repeat finding the next middle value. So this will be in the while statement as well. So you're going to have 0, 1, 2. And basically, you're going to do 0 plus 2. Divide that by 2. And you get 1. So we know that the middle value is 1. The index is 1. And at index 1, we see that it's 9. And we see that 9 equals the target, which is 9. We will just return mid right here. And you would do this step vice versa, even if it's at -1. But you should keep in mind that your while statement is what would be like while left is less than or equal to right. And that's because you'll have a point where, like, say we're searching for 12. If we're searching for 12, there will be we'll just reuse this right here because just to simplify the video. But basically, if you would just redo the steps and it'll lead to 5, 9, 12 again. And we see that the middle value was 9, just as we found earlier. And we see that it doesn't equal to the target, which is 12. Target is 12. So you want to shrink the window again, and you'll delete everything, including like everything to the leftmost. So 9 is less than 12. And then you also delete the middle value. And we'll see that 12 is right here. And we saw the left and right. So the right pointer was at 12, and the left pointer was at 5. And the middle pointer was at 9 in this instance. But once we do this, the left, right, and middle are all in the same position. This is what we do if left is less than or equal to right. So hopefully this makes sense. Now we're going to implement it into code. So basically left, you'll make 2 pointers, like I said, left equals 0, and the right pointer will be at the end. So the length of nums minus 1. And you also will want to calculate the middle value, which is left plus right divided by floor division by 2, just as I said earlier. So now you want to do a while statement. So while left is less than or equal to right. So while left is less than or equal to right, you're going to want to compare the value. So if nums, you're going to want to compare the value of nums mid. Just like earlier, we want to compare if nums mid is less than the target. So target in this instance was 9, and the middle value was 3. So you're comparing if there's 3 less than 9, or there's 3 greater than 9. And that would be the question. So basically, we can see that 3 is less than 9, obviously. So we're gonna want to shrink the window. So since 3 is less than 9, you're gonna want to forget about everything in this area, including the middle value. And this will be the new window. So you're gonna want to reassign the left pointer to be mid plus 1. So if nums of mid is less than the target. Now here you're gonna want to do left equals mid plus 1 to shrink the window. If nums of mid is greater than target. So here's where if the value is greater. So here you can just do right equals mid minus 1. And now if everything else, if none of these conditions hit, you'll just return the value of mid. And then if none of this is true, if you can't find any of this, you'll just return -1. And basically, the solution should work. We're going to run it first. Let's see if it runs. Looks like it's not running fully, so we'll check why. So while left is less than or equal to right, if nums of mid is less than the target, you do left equals mid plus 1. If nums of mid is greater than target, right equals mid minus 1. Else you'll just return the middle value. And then you return -1. Okay. So I guess you can just return -1. Left was 0, 1. Oh, so we didn't recalculate the middle value like I said earlier. We want to always constantly recalculate the middle value and during the while statement. So you'll do mid equals left plus right divided by 2. And that's because in the while loop, every time it runs, you wanna make sure every time you shrink the window or increase the window size, you'll recalculate the middle value. And if none of this hits, it'll return -1. Sorry if I made that mistake. It's 2:40 a.m. right now, so that's currently the answer. Thank you.